Hello friends, in this editorial we are going to discuss Leetcode weekly contest 401. Okay, and our first problem is find a child who has the ball after k seconds. Okay, basically we have to find a child who has the ball left with him after the k seconds, means after the given number of time. So basically there are integers n and k. N denotes the children and k denotes the seconds. Okay, so we have been given a ball. Is that clear? We have been given a ball and we have to pass it to next child in k seconds. In 1 second it will, and in 1 second we can pass a ball to only one child. So basically we have been given k equals to 5. So in 3 seconds we have been passed the ball to the last child. And what the problem statement says, we have to again reverse the order and reverse it to the, and means we have to give this ball to another boy, means we have to go back again. So okay, we have been done with 4 seconds and at last we have been done with 5 seconds. So the basically the index of these boys are okay. So at last we have got the ball with the boy at index 1. Okay, so in this way we have to just run a loop in reverse direction. Okay, means we have to just run this in circular direction till the number of seconds over. As the time is over and the ball is in hands of which boy, we have to just print that index. Okay, so basically this is the problem statement and nothing is more than that. So how we will solve the problem? Okay, basically how we will solve the problem, let's discuss that. Yes, so for example you have been given 4 childs. Okay, so and you have to run a for loop here, just simple for loop you will run. We have been given the positions 0 1 2 3, 0 1 2 3, and the direction. Okay, basically in this direction in left to right the indexes are increasing by 1. Okay, the indexes are increasing by 1, and in this direction from right to left the indexes are decreasing by minus 1, they are decreasing by 1. Okay, just just see that the indexes are increasing from left to right and they are decreasing from right to left. So what we will do is just a simple thing, just we will do a simple thing here. What, let's understand from the code one time. So what basically we will take here, we will take position we will take 0, means as you can see here the first child is at 0th index, so that's why we have taken position equals to 0. And then what, direction, then we will take direction equals to 1. As we are starting from left to right, so direction will increase by 1. Okay, then we will run a for loop for I in range k. Okay, we will run a for loop here. So basically in this for loop the for loop will run till the k seconds. Okay, and it will till close, means the for loop will close until till the time is over. Okay, so first of all when it goes in left to right direction, okay, when it goes in left to right direction the position, means the position with respect to direction increases. Okay, as you can see here our position is increasing with respect to direction. Position with respect to direction. Okay, how come? Means as we are going from left to right. Okay, as we are going from left to right our positions are just increasing. First 0, then 1, then 2, then 3, they are just increasing by 1, and our direction is 1. Okay, as you can see that our direction is equals to 1, So our position is increasing by 1. Okay, done. So so basically now what we will check, if if our position equals to 0, 0 means the position is at first point. Okay, means we are at the first point. If it is 0, then our direction will be just 1. ओके, मीन्स पोजीशन 0 है तो लेफ्ट टू राइट डायरेक्शन में जाएगा, है ना। लेफ्ट टू राइट डायरेक्शन में जाएगा तो हमारी डायरेक्शन 1 से इंक्रीज होंगी, है ना। अगर ऐसा नहीं है, अगर हमारी पोजीशन मीन्स इफ आवर पोजीशन is at last index, means we are at last point. Basically we have 4 children. Okay, so what we have, 0 to n minus 1. Okay, means 0 to 3. Is that clear? So basically our last position is n minus 1, means अगर हम means we are at last position, अगर हम लास्ट पोजीशन पे है तो हमें वहाँ से रिवर्स लेना पड़ेगा, मीन्स वी हैव टू रिवर्स. सो वी हैव टू जस्ट डिक्रीज द डायरेक्शन. ओके, मीन्स -1 हमारा इंडेक्स क्या होगा, डिक्रीज हो जाएगा. ओके, सो बेसिकली ये होगा. और एंड देन व्हाट वी विल डू, जस्ट रिटर्न. just return position. What हम just we will just return the position with respect to the direction. Okay, yes. So let's try to submit the code. Yes, it's accepted. So now let's talk about the next problem statement. So our next problem is find the nth value after k seconds. Okay, so basically what we have been given in this problem statement, we have been given two integers n and k. Okay, and an array of n integers whose size is n. Okay, so basically we have been given a of I equals to 1, and we have what we have to do is just do the addition one after the other numbers. Okay, let's take an example. For example, we have been given n equals to 4. Okay, and k equals to 5, k equals to 3. Let's suppose n equals to 4 and k equals to 3. So basically at k equals to 0, k is basically the time. So at k equals to 0, the array will contain these elements, and at k equals to 1 we will add up the elements. Okay, 1 plus 1 equals to 2, 2 plus 1 equals to 3, and 3 plus 1 equals to 4. So basically this is the approach in this problem statement. Okay, and then at k equals to 2, at k equals to 2, basically it will have, wait a minute, yes, at k equals to 2 we will have at first element 1, then 1 plus 2 equals to 3, 3 plus 3 equals to 6, and 6 plus 4 equals to 10. Okay, so basically at for k equals to 3 we have got our largest element, so we have to just print the largest element in this problem statement. Okay, as this problem is very large, so we have to take modulo of 10 to the power 9 plus 7. Is that clear? So basically how we can solve this problem? Okay, we can use a technique of prefix sum. Basically we can use prefix sum. Okay, we are going to discuss in this problem two approaches, one prefix sum and one combinatrix by combinations, Pascal triangle. Okay, so these two techniques we are going to use. So now let's discuss. First of all, what we will take first of all a list. Okay, we will take a list of pref sum. Okay, we'll just take a list here, and what we will do, we will just iterate through it. Okay, we will just iterate through it. For example, wait a minute. Prefix sum of I equals to prefix sum of I minus 1 plus prefix sum of I. Okay, so this technique we can use here, modulo mod. So basically this approach we can use in this problem statement. Okay, so for example, let's try to discuss it by some easy approach, means easy way, by example. So basically we have been given n equals to, for example, wait a minute. Yes, for example, let's suppose take n equals to uh, let's suppose take n equals to 4 and k equals to 6. Okay, take n equals to 4 and k equals to 6. Is that clear? So basically what our list will have, list prefix sum will have 1 1 1 1. Okay, so this will be the contents of our list. So at for iteration at I equals to 0, for I equals to 0, our ps of 1 equals to 1 plus 1 modulo mod. Okay, 1 plus 1 modulo mod. Okay, so for our k equals to 4 and k n equals to 4 and k equals to 6. Okay, so basically for at I equals to 0, we will update our prefix sum. For example, I take prefix sum as v, or v will be 1 plus 1. Okay, it will increase and it will modulo 2, it will become 2, means 2 will add to this, then 2 plus 1 3, then 3 will add, then 3 plus 1 4, and after adding we will get our, at first iteration we will get 1 2 3 4. Then our second iteration at I equals to 1. Okay, it will be 1 3 3 4. Okay, 1 plus 2 will be 3. Okay, here 1 plus 2 will be 3. Then subsequently then 3 plus 3 6, and then 6 plus 4 10. Then subsequently at iteration and third, means at I equals to 2, same will be happening, it will be incrementing one by one, and then iteration 4. Okay, as you can see, and then iteration 5, it will be just incrementing, and then at last iteration 6 for. So in this way our 6 iterations are over, and at last we get a final output as 84. It's the largest element in this here. Okay, you can go through it one time, and if there is any doubt you can ask me. Okay, so now discuss our code one time. So basically in this code I have initialized v of v as a prefix sum list. Okay, our v is our prefix sum list. Okay, wait a minute. V is our prefix sum. Okay, and we will initialize the list of size n with all elements as 1. Is that clear? And then for I in range k we'll run a for loop and again a for loop. Okay, we will run 2 for loops. Is that clear? And then we will initialize the main prefix sum formula, and just we will return the prefix sum v of n minus 1. N minus 1 means the last element. Okay, our list starts from 1 to n minus 1. 1 to n minus 1. Okay, so n minus 1 is basically our last element, so we have to just print our last element as you can see here. Okay, so you can just go through it one time. You can see the code and also this approach also, and if there is any doubt you can ask me. Just go through it one time. Okay, so now let's discuss our next approach, Pascal triangle approach. Okay, so basically what's a Pascal triangle? It basically goes on adding and adding. Okay, so basically a Pascal triangle goes on adding 1 1 2 1 1 3 3 1. Okay, 1 4 6 4 1. So this is a Pascal triangle. Okay, now let's discuss the problem approach. Okay, so now we are going to discuss our first problem, first test case. Okay, this one. So we are going to discuss our first test case. So at row equals to 0 it will be 1 1. Okay, at row equals to 0 it will be just 1 1. Then at row 1 it will increase as 1, it will just divide up, and then row equals to 2 it will just divide up, means 1 plus 1 equals to 2. 1 will be as it is, and then 2 plus 1 equals to 3, and again 2 plus 1 equals to 3. Then 1 3 3 1, as you know, 3 plus 3 6, 3 plus 1 4, and 3 plus 1 4. So in this way the things are going added up. Okay, so basically, so now basically what's the main approach, what the main approach tells us. Okay, you can see here in this in left side you can see here our first at k equals to 0 it is 1 1 1 1. You can see it is 1 1 1 at k equals to 1. Okay, at k equals to 1 what it is, it is 1 2 3 4. Okay, no, you can see just at k equals, then at k equals to 2, at k equals to 2, let's see, it is 1 3 6 10. As you can see in this Pascal triangle it is 1 3 6 10. At k equals to 4 what it is, it is 1 4 10 20. As you can see here it is also 1 4 10 20. Okay, at k equals to 4 it is 1 5 15 35. Again it's 1 5 15 35. Then at last k equals to 5. Okay, at k equals to 5 it is 1 6 21 56. Okay, and now at last we have got our final element 56. Okay, so this is a basic Pascal triangle approach. Okay, so in this we will use combinatorics. Okay, combinatorics in Python there is a file, means we have to import combinations. Okay, we have to just import combinations. So basically in a Leetcode it is inbuilt. Basically a combination of A and B just calculates the way to choose B element from a set of A element. Okay, basically in this we have been given n and k. Okay, so we have to just find the combinations of n and k, which is n factorial upon r factorial into n minus sorry n factorial upon k factorial upon n minus k factorial. Okay, so this is the basic combination formula. Okay, means k identical items are distributed in n distinguishable bins. Okay, in this k identical items are distributed in sorry in this n identical items are distributed in k distinguishable bins. Is that clear? So this is the basic approach, and it will run in just a simple way, like it will just run in k plus n minus 1 to n minus 1. Okay, basically k plus n minus 1 factorial. Yes, it is just k plus n minus 1 factorial to what, to k plus to n minus 1 factorial to just wait a minute. Yes, to just k plus n minus 1 minus of minus n minus 1. Okay, 2 plus k plus n minus 1 minus of n plus 1 factorial. Okay, in this n will cancel and 1 will also cancel. So basic formula will be k plus n minus 1 factorial upon n minus 1 factorial upon n minus 1 factorial to k factorial. Okay, so this is our basic formula which is going to use, and it's a Pascal triangle approach. You can see this. Okay, let's one time talk about some another example of Pascal triangle. For example, this one. Yes, second example. So basically let's discuss our second example for n equals to 5. Okay, for n equals to 5 and k equals to 3. So basically we have got our simple answer. Okay, so basically this is our answer. Yes, this is basically our answer. Okay, so now our answer is 35. So basically by this Pascal triangle approach you can solve the problem. And now let's try to discuss with the help of combinatorics method, means Pascal triangle approach. Okay, yes, we will just return comb of k plus n minus 1 till n minus 1. Okay, till n minus 1 modulo mod means 1007. So yes, basically this will run appropriately. Let's try to submit. Yes, it is accepted. Let's suppose I write the formula of explanation of form. It's basically equals to, means calculate number of ways to check. Okay, to check means check k elements from set of n elements. Okay, means k k choose n. Okay, so this is our basic approach. If you have any of the doubt in this approach, you can ask me in the comment section. Okay, so thank you. Basically our next problem is maximum total reward using operations 1. Okay, so basically in this problem statement we have been given an integer array. Okay, integer array known as reward values whose length is n. Okay, it represents the values of reward initially. So first of all, the reward x is at 0 and all indexes are unmarked. We have to perform operations any number of times. So basically the I is from 0 to n minus 1. Okay, and reward value I is greater than total reward x. Okay, then we have to add reward values of I to x. Okay, we have to increment x by reward values. So basically we have to return an integer denoting maximum total reward we can collect by performing operations optimally. Okay, so basically what the problem statement says that we have to choose the indices in order and print the maximum reward we can collect by performing the operations. Okay, so basically we have been given an array 1 1 3 3. Okay, we have been given an array 1 1 3 3. So we have to perform operations on it. Okay, and find a total maximum reward. So basically maximum reward can be found at 0 and 2. Okay, so which is giving us value 4. Okay, so these are giving us the reward values. Is that clear? Basically, hey, let's talk about a second example. 1 6 4 3 2. In this index 0 1 2 3 4, in this index 0 2 and 1 in order will give us the total reward value 11, which is the maximum one. Okay, this will give us the reward value as maximum. So basically in this our current element must always be greater than our prefix sum. Okay, our current element is must always be greater than our prefix sum. So let's discuss how you can keep it. So basically we can keep it by sorting an array. okay, by sorting an array. We just have to sort the array and solve the problem. So basically our original one is 76432. After sorting it will be 1, 2, 3, 4 and 6. Okay, now we can select the elements. Okay, and its prefix sum will be 1. 1 plus 4 5, 5 plus 6 11. So basically this is our prefix sum. Okay, basically basically our reward values means we have been given the constraints. Okay, our reward value, length of our reward value must be less than or equal to 2000. Okay, and our reward values may also be less than equal to 2000. So these are our constraint given. So basically if our n is greater than 2000, it will be basically give us time limit exceeded, TLE. This error it must give us. So basically to avoid these kinds of error we must use only single type of approach. Just keep n smaller than equal to 2000. Also reward smaller than equal to 2000. So basically in this way 2000 multiplied 2000 just give us 4 to the power 4 into 10 to the power 6. Okay, so basically this is our main constraint. Okay, in this if we have been given an array of 5 elements, a1, a2, a3, a4 and a5. Okay, so we have been given an array of 5 elements. Okay, so basically we have to sort the array. Okay, and keep the last element means the biggest element less than equal to 2000. If it is above it, so it will just give an error, means smaller than equals to a2, smaller than equals to a3, smaller than equals to a4, smaller than equals to a5, and it must be smaller than or equal to 2000. Okay, just a simple approach. So in this problem statement we are going to use dynamic programming approach. Okay, first of all, first let's note down the step. First we will sort. Okay, then what we will do, we will set dp. We will set our dp to store possible sums that can be achieved at each step. Initially the sum will be 0. Okay, then what, then we will run for loop. Okay, then what, then we will update the dp state. Update dp set. Okay, means for each reward we will create a new set dp, means new dp to store updated sums. Okay, so basically for each current sum in dp, if the reward can be taken, means if, wait a minute, yes, means is if reward is greater than current sum. Okay, if reward is greater than current sum, okay, we will add the sum of the current sum and reward to new dp. Okay, just this only, this one, we will just add the current sum to the, add the current sum and reward to the new dp. Okay, so basically we will always add current sum itself to new dp to account for possibility of not taking the reward. Okay, So basically after processing all current sums, we'll update dp to be new dp. Is that clear? And then at last what we will do, we will just return max of dp. Just return max of dp. Is that clear? So these basic 5 steps we have to do to solve this problem statement. Okay, so let's try to understand with the help of an small example. For example, we have taken 1 6 4 3 2. First step, sort. It will be 1 2 3 4 6. Okay, it has been sorted. We'll initialize dp to 0. Initialize dp to 0. Okay, so sum is 0 only. We will iterate through rewards. Okay, means we'll iterate through all reward. Means for example, for reward 1. Okay, for reward 1, basically for reward 1 our current dp is 0. Okay, our our new dp becomes 0 comma 1. Okay, means it will be 0 plus 1 comma 0. Okay, so at reward 2, basically our dp will be our current dp. Our current, what is our current dp, is basically 0 comma 1, and our new dp will be 0 1 2 3. Okay, so this will be our new dp. Is that clear? So now for reward 3, our current dp is 0 1 2 3. Okay, and our new dp is basically 0 1 2 3 4 5 6. Okay, is that clear? So now our at reward 4, at reward 4 our current dp is basically 0 1 2 3 4 5 6, and our new dp is basically what, means our updated dp is 0. Our new dp is basically what, 0 1 2 3 4 5 6 7 8 9 and 10. Okay, so basically this will be our new dp. Is that clear? And at reward 6, basically at reward 6 our current dp is basically what, 0 1 2 3 4 5 6 7 8 9 10. So basically this is our current dp. And what will be our new dp? our new DP 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. Basically this is our new DP. Okay, so for 5 rewards we have got our 5 DPs. Okay, at DP1 it's 01, at DP at reward 2 it's 0123, at reward 3 reward equals to 3 it's 0123, at reward 4 it's 0 to 10, and at reward equals to 6 it's 0 to 16. Means the DP goes on adding after element. Okay, so basically this is the main approach. Okay, this is the main approach, means how you must be thinking. You must be basically thinking that how we got this 16. How we got this 16, let's understand. 1 6 4 3 2. Okay, this is our DP and this is our sorted one. 3 4 6. Okay, first it is 1, then 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, and 10 plus 6 16. So basically this is a prefix sums. Okay, we have taken out prefix sums. So the maximum value of DP, or maximum value of DP, is basically what? 16. Okay, this is our maximum value. Okay, we iterated through loops and we got our maximum value. Okay, so basically this is our basic approach. Okay, so let's try to understand it with the help of a example. Okay, example in the sense, let's try to understand it by code. So basically, first of all, what we will do, first of all we will sort sort the reward values. Okay, we will just sort the reward values. Yes, we will just sort the first reward values. This is our first one, first initialize. Okay, then what we will do, we will initialize the DP set. We will just initialize the DP set. DP dot add. Okay, yes, let's write a comment. Sorts the array. Okay, yes, DP dot set uh, set DP is set DP is used to store. Yes, set DP is used to store the possible sums that can be achieved at each step. Okay, initially only possible sum is 0. Okay, we have set DP to 0. Okay, then we will run a for loop for reward, in reward for reward in reward values. Okay, we'll run the for loop, means iterate each reward in the sorted reward values, means it will iterate through each reward values in each reward in sorted reward values. Okay, then we will, what we will do, we will just update, we will just update the dp set. Okay, what we will do in this update dp set, yes, new dp, we will just create a new dp. Okay, we'll create it a set. Okay, new set dp to star updated sums, a new dp set to store updated sums. Okay, is that clear? So we have updated the dp, then we will run a for loop for current sum in dp. Okay, we'll run for loop, then we will check if if reward is greater than, okay, if reward is greater than current sum. Okay, when we will, then what we will do, we will just add, what we will add, new dp, in new dp current sum plus reward. Okay, this thing we will add. Is that clear? Then what we will do, we will now add new dp dot add current sum. Okay, and then initialize dp equals to new dp equals to new dp. Okay, and then we will just return maximum dp. Okay, just return the maximum dp. So basically, let's try to understand first, then for each current we will okay, we have run the for loop. Okay, so basically for each current sum in dp, if the reward can be taken, that is if reward is greater than current sum, add sum of current sum and reward to new dp. Okay, for each current sum in dp, if reward can be taken, that is reward greater than what, current sum, then add the sum of, wait a minute, current sum, yes, then add the current sum and reward to dp, current sum and reward to dp. Okay, so this we will do next year. then always add current sum itself to new dp. Always add current sum itself to new dp. Okay, to account for possibility of not taking the reward. To account for possibility not of not taking the reward. Okay, and after processing all current sum we will after processing all current sums, okay, we will update dp to new dp. Will update dp to be new dp. Okay, and just at last we will return the maximum of dp. Okay, means return maximum value in set dp. Okay, which represent maximum total reward achievable. Okay, is that clear? I think you must have got the code. Okay, so let's try to submit it. Runtime error invalid syntax for reward in reward values. Syntax error is giving error. Okay. Basically, what happened for rewarding? Okay, I got that. I got that. A normal one view values. Yes. Now let's try to submit it. For each current sum in DP reward can be current. What's happening here? Where did the broader dots come here? I don't know. One time let's try to run the code. Yeah, it's finished now. It's not giving an error. Yeah, basically it's giving wrong answer. Okay, now let's try to debug this code. Basically, I think new DP must be. I think now it must be got submitted. Yeah, it's now get accepted. So you can go through the code and explanation, and if there is any doubt you can ask me in the comment section.